Hey, good evening, everyone. This is Celso Batalha, and I am using Zoom.us inside or bundle with our Canvas course for the first time. So I don't know if everything is going fine, and I would like to go over what we have in the course today. And this week, as I mentioned yesterday, we have a exam going on and on Wednesday, and I will open, and I have the exam open one day for 24 hours. You have 1 hour to give your shot, or 70 minutes, 1 hour and 10 minutes. And then you can try again the next day. So, which means tonight and midnight exam is going to be over, and you have the entire Wednesday to try and give a shot at your exam. So first of all, I would like to see where we are. We are developing the chapter on telescopes and light. But yesterday in the chat room, since moon's phase is going to be an important component of our course, I keep telling students, I mean, you are going to forget most of the technical terms 6 months from now once the course is over. But one thing that will not stop seeing is the moon in the sky. So if you can learn how to identify moon's phases and have some quote relationship with the moon, better for me. So I think I accomplished something. And I really would like you to get to know our natural satellite and also use simple sky observations to not only identify which phase the moon is going through, but also which position the moon is with respect to its orbit around Earth and its position with respect to the sun, but also to make predictions at what times certain moon phases are supposed to rise and which phases are supposed to set. So for that, I would like to where is it? Just a moment. Okay, so let's do a little bit of drawing. And I hope you can follow that. It's very simple. So first, I'm going to do some drawing. And my expectation is when we are done with a simple drawing, and you have to be able to do yourself. So you have to be able to repeat the same steps I did. And then you can kind of boast that you know about moon's phase. So all of what I'm going to say is based on a vantage point from the northern hemisphere. So if you go to the southern hemisphere, things get the other way. But I'm not going to discuss that right now. So I'm going to focus as if we were observing the moon from the northern hemisphere perspective, and then we're going to go from there. First of all, when you draw the moon's phase, you have to know there are basic moon's phases. So we have to know there is a new phase, right? And then there is a first quarter, and then there is a full moon. So I'm pretty much putting out the most kind of obvious one, and the third quarter. So 1, 2, 3, 4, 5. So how do they appear in the sky? So a new moon doesn't appear, so you don't see anything. First quarter, as you see in the sky, is a moon that half of it is lit by the sun, the other half is not. So here, black means bright. Black means bright, okay? So which means this part of the moon, which is your right-hand side as you see, happen to be bright, okay? Full moon is entirely bright. And then third quarter is half of the moon is bright, but see, now the brightness is to the left. This is how we see in the Northern Hemisphere, okay? Now, where are these moon phases with respect to its orbit around Earth and its position with respect to the sun? That's our next step. So first we have to draw or indicate where the sun is. So sun casts out radiation and light. So let's represent the sun by, a bunch of light rays, and here is planet Earth. Now, planet Earth and the sun are being seen as if you were standing north of Earth and north of the sun. So in other words, you are seeing the system from way above north in a position that is pretty much coinciding and close to the North Celestial Pole, and then you're looking down on that system. So if this is true, Earth goes around the sun following a counterclockwise direction. So if the sun is somewhere to the left, the moon goes around the sun like this on its yearly revolution, right? But not only that, this Earth also rotates around its axis of rotation, which gives rise to days and night, in a counterclockwise direction, the same way. So the revolution is counterclockwise, the rotation is counterclockwise, and that's what I'm trying to represent here. To the point that if I want to represent here on Earth the time of the day closer to 6 a.m., that would be the location. So somebody stands here, looks at her watch, and then she's going to read something around 6 a.m. Why is that? Well, look at this. If this dot in the center represents the North Pole, this person is standing at the equator, right? The circumference of Earth, if this is North Pole, this is pretty much close to the equator. So because Earth rotates in a counterclockwise direction, so this person at 6 a.m., a few hours later, is going to be here. The sun is already up in the sky. Few hours later, more particularly 6 hours later, the person is going to be here. And if that person looks straight up, is going to see the sun crossing meridian. And what time of the day this is? Noon. Now, 6 hours later, because of Earth rotation, this person is going to be here. This is 6 p.m. And then 6 hours later, the person is going to be at this location I'm indicating, and pretty much at midnight. So at midnight, you can't see the sun, as you well know, but you are in a very comfortable position to see skies up in stars up in the sky. Okay, so if we were to erase everything, and you start all over, imagine I should be able to do that quickly, like in a big erase button. Not use this rubber eraser. So I will start again by representing where Earth is. And there you go. Where is it? Got my eraser. That's Earth, North Pole. And now let's place the moon in the sky. So to place the moon, let's start with the moon in the new phase. The new phase is a phase where the moon happens to be located somewhere between the line connecting the sun and the earth. So if you have a line connecting sun and earth, the new moon is somewhere here. And by the way, this is not indicating any sort of a scale. The moon is a quarter size of Earth, and it's about 30 Earth diameters away. So it's really not in scale, but it helps to give you some perspective. So right here, I'm indicating the new moon. Okay. Now, as Earth goes around the sun in this counterclockwise direction, as Earth rotates around the sun in the counterclockwise direction, by the same token and because of the same processes, because all these objects came from the same circumstellar disk, so the moon goes around Earth also following a counterclockwise orbital motion, which means knowing that the moon goes around the Earth and takes about a sidereal moon, which is 27.3 days. So the moon takes about 7 days to complete a position that will place it somewhere in here. So this position, see the moon is always half lit by the sun, no matter where the moon is. So if the moon happens to be at this position, the hemisphere of the moon that faces the sun is half lit, right? Is same thing here. So the moon is always half lit by the sun's radiation, by the same token that Earth is half lit, right? So this is Earth half lit right here. But the main point is the moon goes from the new phase to the first quarter, to the full phase, and then to the third quarter. So to better understand the moon's phase, you should be able to reproduce this simple sketch. So you initiate with the moon, with the sun and the sun rays, and then you place Earth in a certain location, right? And then you place the moon, initiating with the new phase, which is the phase where the moon happens to be lying between the sun and Earth. First quarter, 7 days later, full moon, 14 days past the new moon, and then the third quarter about 21 days. Okay, and then you have the 4 main phases described. Now, you certainly have heard about waning phases and waxing phases. So waning means growing bigger, and the waning phases are all the phases that lie between the new moon and the full moon. So those are called waxing phases, growing bigger. Why waxing phases? Because as you see in the sky, the moon appears to be new. That's how you see it. And then you see the moon growing bigger, which means as you see, that bright part is facing to your right-hand side, and we call this a crescent phase. The first quarter, as you see, appear in the sky like this. That's how you see appearing in the sky. That's the first quarter. That's how you see it. The moon phase appear in the sky as you see it, like this. In the space, it's always half lit by the sun, with the half lit hemisphere in my sun configuration always set to the left, like here, for instance. But as you see in the sky, when you go to the waning phase, now the bright, I forgot the third quarter phase, as you see in the sky, is bright on the left. And the waning, so those are the waning phases. Waning phases, they run from the full phase to the new phase, and it passes through the third quarter and then to the crescent phase. Now the crescent phase has a tiny bright lit area to the left. So this is a crescent waning phase. Now, I forgot to include a phase between the first and full moon that is called the gibbous phase. Gibbous phase. Gibbous phase. So the gibbous phase, in the waxing, it appears as if the shining part, this is the fuzzy one, the one that I'm representing now is fuzzy, but the edge of the moon that is sharp and nicely defined is seen to the right. That is the waxing gibbous. The waning gibbous phase, as you see in the sky, the sharp edge of the moon is to the left, and the fuzzy part is to the right. So here I'm indicating the waning gibbous phase, and finally the waning crescent phase. So to initiate the study of the moon phases or moon's phases, you should be able to reproduce this sketch. And just to make it clear, I'm going to do it again. But now I'm placing the sun in the other side. That's the sun ray. Doesn't matter where you point in the sun ray. You just need to follow conventions. So sun phase, place the Earth. So the Earth always is rotate and orbit in a counterclockwise direction. So if you want to indicate 6 a.m., this is 6 a.m. 6 a.m. If you want to indicate noon in this configuration with the sun to the right, you have your noon time. If you want to indicate 6 p.m., that's where the sun is with respect to the observer. And if you want to indicate midnight, that is the position for midnight. The sun is not on view. Now let's place the moon again. Well, the new phase appears right here between the sun and Earth. As you see in the sky, you see nothing. Here's the new phase. Now, following the new phase, the next phase is the waxing crescent phase. So waxing phases are phases that goes from new moon to the full moon. Here's the full moon, right? This is the full moon. As appear in the sky, the full moon is completely lit, as we see in the sky. As we see in the sky, it's completely lit. If you are in the space looking down on the system, Earth, Moon, and Sun, that's how you see. Half of the moon is lit by the sun. But as you see by somebody standing on Earth, then the moon is entirely lit because you are here, right? You are here, and you look up and you see the moon half lit the way it is. Just a second, somebody's calling. Sorry about that. Now, so the new phase follows the waxing sequence of phases. So the waxing, since the moon orbits the Earth in a counterclockwise direction, now those are the path associated with the waxing phases. So crescent phase was when the moon happened to be here. If you are standing north, look now on the moon, this is what you see. But if you are on Earth and you look at the moon, this is what you see. This is what you see. The waxing, crescent phase, crescent phase. And then following that, you have the first quarter. That's the moon I see in the space for somebody standing north. As you see in the sky, the first quarter is the same. Same. And then it follows the gibbous waxing phase. I see in the space by somebody standing north. This is what you see. In the sky itself, that is what you see. This is a fuzzy terminator. We call terminator that fuzzy area where light and darkness meet. And here's the moon. And then we have the full moon. So those are the waxing phases. And here's the gibbous phase. Okay. Now, past the full moon, the sequence of phases are the waning phases. So here are the waning phases. And the waning gibbous phase, as we see in the sky, now the sharp edge of the moon is seen to the left, like this, if you are in the northern hemisphere. This edge here is sharp. If you put a telescope there, it appears nicely resolved. So we are talking about waning. Where is the razor? We are talking about waning gibbous. And then we go to the last quarter, as we see in the sky, standing north, that's what appears. But as we see here from Earth, that's what we see. We see half of the moon lit, and the lit part is to the left. That is a waning third or last quarter. And then we follow with a crescent phase, something like this. It's a beautiful moon. You can only see 3, 4 in the morning. Okay, that's a waning crescent phase. So you should be comfortable in reproducing these phases before we can go further and learn to identify and predict position. So the last step is, how can we predict position, or at what time of the day certain moon phases are supposed to rise or set? So rising moment is when the object comes from or appears as if it comes from below horizon to above horizon. And setting phases are when the sky object goes from above horizon to below horizon. Let me show you what rising and set is. I think I already showed yesterday. See if I can bring this to your attention. So I'm gonna speed up time. There you go. See these stars over here? They are rising. They are coming from below horizon to above horizon, and they rise in the eastern sky. And if you want to see them setting, we have to look and spy them in the western sky. Now it's 11, but pretty soon it's going to be 5 o'clock, 6 o'clock, and the sun is setting in the western sky, as you can see. And the moon is going to be setting in the western sky right after as well. And Ophiuchus is setting, and the stars is setting, and then another day is coming by. and eventually the sun rises again in the next day. And that's what we have, the beauty of the diurnal motion. Okay. Now, the last thing that I would like to show you with respect to time of the day, that certain phases are supposed to rise or set. Let me give you some tips. For instance, I might ask you a question: at what time of the day the waning crescent phase is supposed to rise or set? Or at what time of the day more likely you would find the full moon in the middle of your sky, pretty much close to meridian line? So how can you answer this kind of questions? My suggestions is to use the T trick, the T trick. So what is the T trick? I'll show you. So let's say you want to find the time of the day, the waxing, I'm inventing a phase, waxing crescent phase, waxing crescent phase is supposed to, let's say, rise, okay? Rise. So to answer this question without memorizing, because you could memorize, if you have a memory of a, an ancient person who lived 5,000 years ago, he could memorize verses because there was no publications, and with information regarding the entire survival knowledge of that particular community, you could. But let's say you don't have those skills. It seems that we lost. Then you have to use some tricks for that. So to find out at what time of the day a waxing crescent phase is supposed to rise, first thing you need to do is to be able to locate the waxing crescent phase in a scale that includes the sun and earth. So let's do that. Here's the sun. Here is earth. Earth is to the right, so earth rotates counterclockwise. And then we have to be able to place these clocks on earth. So this clock here indicates what time? Very good, 6 a.m. I'm pretending you got it right. And here is noon. Sun is up in the sky. It's 6 p.m. and midnight. Okay. So now we need to be able to place waxing crescent phase in this diagram in respect to Earth and the Sun. So where is the waxing crescent phase? Well, how do you figure? My recommendation is start placing the new moon. You know the new moon is lying between the Sun and Earth, so here's where the new moon is. And then the waxing phases, you must know that, are all the phases that goes from new to full. Since the moon goes counterclockwise and the full is over there, so the crescent phase should be here, right? So it's a crescent waxing phase because those are the waxing phases between the new and the full, and it's a crescent because it lies between the observer, which is Earth, and the object, right? The object lies between the light source and Earth, the observer. So that is the waxing crescent phase. So you place the moon in the proper place. And then that's why I call this the T trick. You make a T. You draw a line from center of moon to the center of Earth. And then you make a T like that. So this point indicates the rising moment. And this point here looks like a happy face, indicates the setting moment. How do you know if it's rising and set or setting? Well, if you are standing right here, right, and since Earth rotates counterclockwise in this direction right here, so if you're standing here, you are going to see the moon appear in the sky in your horizon at this moment right there. which means 9 a.m. 9 a.m. 9 a.m. And 9 p.m. 9 what? Why 9 p.m.? Well, because 9 p.m. is between 6 p.m. and midnight. So at 9 p.m., if you're standing here, you look west and then you see the moon in there, right? You see the moon in there, right there. But a few hours later, you can't see anymore because Earth is in the way. So a waxing crescent phase rises somewhere around 9 a.m. in the morning and sets somewhere around 9 p.m. Somewhere. So let's try another one. Give me one. So no one is there. That sucks. Okay, let me get a waning gibbous. Waning gibbous. So let's change the position of the sun. Place the sun in there. Place the Earth somewhere. Center of Earth. And then you bring the moon and define where the moon is in the waning phase. Okay, so you have to know that. So how do you know where the waning phases are? Well, I recommend that you place the moon in the new phase, which is somewhere here. Since the moon goes around Earth in a counterclockwise direction, that's how the moon goes around Earth, counterclockwise direction. So those are the waxing phases all the way to full. So you want the waning phases. The waning phases are those. So gibbous is the phase closer to the full. So here is the gibbous waning phase. Okay. So to find out at what time it rises and sets, what do you do? T-trick. T-trick. And then you have to establish the time. For instance, this time of the day here on the top part is 6 p.m. It is 6 p.m. because since Earth rotates that way, few hours later, you cannot see the sun anymore. Past 6 p.m., you don't see the sun. It is midnight, 6 a.m. And here is noon. Which means these phases are such that you start seeing the waning gibbous phase at 9 p.m. This is the rising part. And here's the setting part, exactly at 9 a.m. Okay? And that's all she wrote. If you have any other question regarding moon's phase, we could perhaps explore internet stuff. Like, look at this, stop. Look at this phase here. Which phase this is in the sky? Let me get rid of daylight. So we are in the north hemisphere. The lead part is to the right? So let me bring the moon to the center and let me expand it. Which star is it? Look at this star, so orange. It's a K5, it's pretty yellow. Okay, so let's expand. I hope I didn't miss it. There you go. So which phase this is? The first thing you should be able, as you see the moon, identify this phase, if you are in the northern hemisphere, as being a waxing phase. Why waxing? Because see, the part of the moon, the edge that is well-defined, not fuzzy like this one over here. The one that is well-defined is to the right? So that is the waxing phase. The sun is to the right of the moon. The sun is, as we say, west of the moon. So this is a waxing phase. Now you have to decide if it's waning, if it's a crescent or first quarter. It's hard to tell I would say is crescent. It's getting close to first quarter, but you could, since this is a software, if I double click, I can give more information. Look at that, 40%, which means 50% would be a first quarter. So it's not first quarter yet, but it's getting there. So basically this phase is a waxing crescent phase. Now, at what time of the day a waxing crescent phase like that rise and set? Well, we just saw, right? It's about 9 a.m., right? Oops, wait a second. There you go. So, well, it's not working. It's rising at noon in our calendar, but it's because there are no circles going around. The orbits are not circular, but it's not so, well, it's kind of far, surprisingly far. And at what time of the day this moon is going to set? So if you follow the whole deal, that moon is going to be setting (9 p.m.), but it doesn't. It's almost midnight. So we have 3 hours off. It's amazing. You can play around also, but you know, in testing, in all the test banks you find or exercise, so you're gonna follow the trick that I just gave you, not the real thing. The real thing is more complicated. The moon has a very wild motion in the sky. So you can Google moons, moon pictures. And then, for instance, this phase here, which phase this is? And then you say, well, if this picture was taken in the northern hemisphere, the part of the moon that is sharp is the right one. It's a waxing. Kind of a half of it is lit. So it's a waxing first quarter. At what time of the day this is rising? Well, that is about noon, and it's setting at about midnight. So you can do those tricks and then you can figure that. So let's take another phase. Look at this one over here. Which phase this is? Now the part of the moon that is sharp is not to the right, it's to the left. This is a waning phase. It's a waning phase and it's closer to crescent. It's more crescent than first quarter. So it's a crescent waning phase, right? And this moon is supposed to rise somewhere at 4 in the morning or 3 in the morning, and should be setting somewhere 3 or 4 in the afternoon. 3 or 4 in the afternoon. So it sets before the sun sets. Okay. So train yourself on these subjects and let me know if you need any extra support. All right.